It began just before dawn on December 15th. A narrow band of data quietly slipped through a solar observatory's filter, almost dismissed as background noise. But then the sequence repeated, precisely. And that was the first clue. It wasn't a burst in the way we understand solar outbursts or gamma events. This had rhythm. This had symmetry. This had intent. At first, the alert didn't even mention 3I Atlas. The burst was tagged as a localized luminous anomaly, a phrase used when no one wants to commit to what they're actually seeing. But it didn't take long before the triangulation came in. The burst wasn't just near Earth, it was tracking almost directly from the same corridor that 3I Atlas was moving through. The overlap wasn't just spatial, it was temporal. This was unfolding in the exact moment 3I Atlas passed a specific distance threshold between the Moon and Earth's outermost magnetopause. That's when the word coincidence started to fall apart. The glow wasn't visible to the naked eye. It required narrowband ultraviolet lenses, the kind used to track ionized atmospheric changes. But when overlaid with prior images of 3I Atlas's trail, the burst landed almost directly within the thin halo left behind by the object weeks earlier. That halo, previously dismissed as diffuse ice debris, now had a point of ignition. Something had triggered it, and the pattern wasn't spherical. It was a thin, expanding lens of light, not unlike a ripple through fog. Scientists called it a light sheet burst, but behind closed doors another word began circulating: imprint. Because the geometry of the glow didn't expand randomly. It followed the same polarization alignment previously detected on the object's tail, the same angles that seemed to sync unnaturally with Earth's magnetosphere last week. That would be strange on its own. But here's the part that froze everyone. Inside the burst's center, a ring-shaped void appeared. Perfectly circular. No energy inside it, only silence. In the world of astrophysics, circular voids that survive energetic events are never good news. They suggest shielding, they suggest control, and worst of all, they suggest intention. What followed next wasn't a flare, it wasn't heat, it was resonance. Earth-based magnetometers, especially those stationed near the Arctic Circle, detected a low-frequency oscillation precisely 3 minutes after the burst. It wasn't chaotic, it was patterned, and that pattern matched something. Months ago, when 3I Atlas first passed Jupiter, the same instruments detected a signal echo when it crossed the planet's bow shock. It's a signature we've only seen one other time, and now it's back. No one is calling it communication, not officially. But behind closed doors, scientists are reviewing past data for echoes. They're checking if this glow was a reply, or a warning. Because when something bursts without heat, it leaves behind a silent ring. And when that silence pulses back toward Earth in a familiar wave, it's no longer just an anomaly. It's a message written in physics, and it's waiting for someone to answer. The glow had barely dissipated when Earth-based observatories noticed something else, a secondary pulse. This time it wasn't visual. It wasn't even electromagnetic in the conventional sense. It was magnetic, but eerily clean. A pulse, devoid of noise, just one sharp fluctuation, like a plucked string in the emptiness of space. And what made it even stranger was where it hit hardest. High in the northern hemisphere, magnetometers buried deep in permafrost, instruments that have remained mostly silent for years, suddenly jumped. Not from solar interference, not from cosmic rays, but from something lower, slower, more deliberate. A pulse that arrived 3 minutes and 22 seconds after the initial burst. It wasn't global, it wasn't chaotic, it was targeted. The signal registered strongest along a curved corridor, stretching from northern Canada across Greenland and down to parts of western Scandinavia. This arc, when overlaid on orbital data, revealed something astonishing. It matched the same magnetic corridor previously altered when 3I Atlas passed near Earth's magnetic equator 2 weeks earlier. That corridor had since stabilized, until now. So what exactly returned? The pulse carried no clear data, no traditional frequency modulations, but its timing was uncanny. It fell into a perfect harmonic sequence when played against earlier resonance patterns recorded during 3I Atlas's pass near Jupiter's magnetotail. Those pulses had been dismissed back then as solar echoes, until now. until this new pulse completed the sequence. 3 pulses, 3 positions, 1 path. In the labs at ESA, a young researcher overlaid the magnetic harmonics into an audio range. What played back wasn't just tones, it was rhythm, deliberate rhythm. Not a song, but structure. Not chaos, but sequence. The patterns bore resemblance to certain mathematical functions. Not natural decay curves, but controlled ones. The kind you'd find in signal compression. And more unsettlingly, the shape of the pulse mirrored something else. When converted into a frequency domain map, the energy spread took the form of a sigmoid wave, rising slowly then sharply before cutting off into silence. This same shape was observed when deep space probes transmitted phased laser bursts back to Earth decades ago. Those transmissions were designed to conserve energy and to be understood. But who, or what, would be sending something like that now? That's when comparisons to earlier events began. A similar pulse was rumoured to have been detected during the Oumuamua passage, though that data was buried under layers of classified review. But this time, the echo was clearer, more direct, and it came after a visible event, a cause, a consequence. NASA's silence on the matter was louder than any press release. The official report simply stated that a geomagnetic irregularity occurred at high latitudes. No mention of timing, no mention of 3I Atlas, no mention of the fact that the pulse originated not from the sun, not from deep space, but seemingly from the thin halo left behind in 3I Atlas's wake. So if the first burst was a trigger, this second pulse felt like a response, not a warning, not a weapon, but a ping, a recognition, a message looking for acknowledgement. The troubling part? Earth responded, not intentionally but naturally. Our magnetic field absorbed the pulse, bent slightly, and resonated back. A faint echo, not created by us but shaped by our planet's own magnetic anatomy. And that means, whoever or whatever sent that pulse now knows we're here, and they know we felt it. When the data from the burst finally landed on the desks of multiple space agencies, it didn't behave the way anyone expected. Gamma-ray signatures are usually aggressive, explosive, and decay with a known curve, whether from supernova, black hole mergers, or magnetoflares. But this one didn't fit any of those profiles. It wasn't chaotic, it wasn't dying, it was organized, and that alone sent scientists into a spiral. Normally, when a gamma-ray event reaches Earth, instruments like NASA's Fermi Gamma Ray Space Telescope and ESA's Integral catalogue them into predefined bursts, long-duration GRBs from stellar collapse, or short-duration ones from neutron star mergers. But this signal didn't decay into background noise like it should have. It sustained for nearly 49 seconds, far too long for a neutron event, far too structured for a collapsing star. Even more confusing was its lack of corresponding heat. GRBs are violent. They leave a thermal signature often extending across X-rays and ultraviolet wavelengths. Yet this one left nothing. There was light, but no burn. Energy, but no residual heat bloom. The absence of thermal decay meant one thing. The energy wasn't radiated, it was transmitted. That distinction changed everything. Instead of energy exploding outward like in a classical gamma-ray burst, this one behaved more like a beam, a tightly controlled stream, and if something is beamed, it implies direction. The pulse was aimed. Satellites above Earth noticed that the burst created a momentary pause in the ionosphere, like someone pressed pause on the upper layers of our planet's atmosphere. Radio reflections bounced higher than normal, high-frequency communications temporarily dipped, and even GPS timing signals jittered by fractions of a second. These aren't standard side effects of gamma radiation. These are the kind of anomalies you'd expect from precision energy targeting, not an accidental wavefront. And still, it came from 3I Atlas. But how? The comet itself wasn't emitting high temperatures. Its composition appeared frozen, stable, boring even. No violent outbursts, no typical signs of rapid outgassing, just a glowing perimeter, and that glow is what changed everything. Scientists at the Subaru telescope in Hawaii ran a back analysis of light scattered by the dust around 3I Atlas. When they compared it to earlier comets, it didn't line up with any known refractive material. In fact, it didn't behave like dust at all. The scattering profile showed high coherence. The dust wasn't absorbing light, It was channeling it, bending it, like fiber optics. And that's when one theory emerged that most scientists still refuse to say aloud, that we might not be looking at natural dust, that this so-called halo might be engineered, a structure, a shell, or something worse, a system. The energy pattern looked less like an accident and more like intention. It matched nothing in our catalogues. It didn't radiate like a dying star or behave like a rogue flare. It curved, it held, it pointed. The waveform contained rise and fall slopes that lined up perfectly with synthetic signal shaping, the same kind seen in early optical relay experiments. But this wasn't coming from Earth, and it wasn't bouncing from a satellite. It was coming from deep space, and it passed through us with a kind of surgical precision. It didn't just light up the sky, it selected a direction, and Earth was in it. That left scientists with an even more uncomfortable question. If the energy wasn't from the sun, wasn't from a dying star and wasn't random, then what was it? Or more precisely, who was it? A scientist combed through the reflected light from the tail of 3I Atlas. They noticed something that should have been impossible. The glow didn't behave like sunlight simply bouncing off the ice or dust particles. Instead, the tail itself displayed a geometry, a repeating structure within the light pattern, almost like a fingerprint etched into the photons. Most comet tails are chaotic, outgassing from volatile ices, solar winds carving away particles, and radiation pressure pushing against debris. It creates a beautiful mess. But this tail wasn't messy. It was symmetrical, consistent, balanced in a way that defied natural formation. And more than that, it responded. Telescopes from multiple observatories noticed that when the gamma burst passed through Earth's orbit, the tail shimmered in a new way. Not just brighter, but more ordered, like a pattern emerging from static. It wasn't random light, it was a field, a controlled, luminous field, as if the tail itself had become a projection surface, or a reactive membrane. This wasn't speculation. Astronomers at La Silla Observatory in Chile layered wavelength captures taken seconds apart and began to detect a rhythmic banding within the reflected spectrum. That rhythm showed spacing between the light peaks that matched a harmonic interval, not unlike those seen in sound waves or musical frequencies, and in nature that simply doesn't occur in light reflection from dust. Which raised one immediate concern: what if the tail isn't reflecting light at all? What if it's modulating it? In other words, what if 3I Atlas's tail is actively shaping the light that passes through it? Not by chance, but by structure. The idea is almost unthinkable in classical astronomy, but something about this burst, and the way it danced across the tail, didn't behave like solar light merely catching on debris. It had rhythm, order, timing. Infrared analysis from the James Webb Space Telescope caught an even more alarming detail. When they isolated certain frames from the observation window, they found that sections of the tail momentarily polarized light. That means it didn't just reflect it, it aligned it. Polarization of that type requires material consistency and orientation. In labs on Earth, we achieve it with filters, wave plates, and specific crystalline structures. But in space, from a comet, there's only one way polarization like that can occur naturally. Ice crystals aligned by magnetic fields. But that wouldn't explain the geometry. The geometry wasn't just radial either. It wasn't coming from the sun and simply stretching away like usual comet tails. Instead, parts of it curved inward, like an incomplete ring or a collapsed helix, a shape that suggested architecture, not explosion. And the light patterns repeated not just across the structure, but over time. That's a kind of coherence that doesn't exist in chaotic systems. NASA's Deep Space Network pointed its arrays toward the burst reflection to try and detect radio echoes, and that's when the final puzzle piece shocked them. A low-frequency hum, barely audible, spread across their sensors in sync with the light variation. It wasn't a signal, it was a resonance, and it matched frequencies typically used in our own planetary radar systems. The tail of 3I Atlas wasn't a byproduct, it was behaving like a component. And so, the question shifted again. If the tail was structured, then was the burst interacting with the comet? Or was the comet producing the burst? What we thought was just a reaction may, in fact, be a function. And if that's true, then we're not dealing with a rogue space rock. We're dealing with an object designed to react to high-energy waves, or possibly to transmit them. Within minutes of the gamma-ray burst sweeping past Earth's orbital field, something subtle began to ripple through our own atmosphere, and at first no one noticed. It wasn't until radio towers in remote regions of Alaska, Canada, and northern Europe began detecting unusual shifts in wave interference patterns that the pattern began to emerge. The signals weren't distorted, they were polarized. Polarization isn't new. It happens every day through sunlight, through reflections on water, through man-made transmissions. But this was different. The polarization shift wasn't static. It pulsed, consistently, in harmonic intervals that lined up precisely with the modulation observed in the tail of 3I Atlas. That was the first red flag. Then came the second. High-altitude weather balloons from Japan's AERA monitoring network, deployed to study the upper atmosphere, returned data showing shifts in the ionospheric boundary, not from solar wind, but from a lateral energy field. The source? Unknown. The direction? Aligned almost perfectly with the direction of 3I Atlas. This ruled out solar flares, it ruled out auroras, it even ruled out low-orbit artificial satellites. Whatever was influencing our atmosphere was coming from deep space, and it was arriving synchronized with the moment the burst encountered 3I Atlas. What alarmed scientists most was how low the polarization dip descended. Normally, fluctuations in atmospheric fields remain high, far above commercial aircraft altitudes. But this event crept downward. It bled through the mesosphere, into the stratosphere, in some regions even touching the troposphere, the layer we live and breathe in. That's almost never seen. For a brief moment, less than 6 minutes, atmospheric sensors in Brazil and India reported mirrored shifts in electric potential across widely separated longitudinal bands. Meaning, the same signal affected opposite sides of the Earth. Simultaneously, there's no known natural mechanism for this. Earth's atmosphere is reactive, but it's not uniform. For two completely separate regions to experience identical polarization flips at the same time in the same waveform requires one of two things, either a global magnetic event or an external coherent transmission aimed at Earth. By the time the European Space Agency joined the data stream, balloon readings from their Arctic Circle research station were showing traces of microwave interference, but not from Earth-bound sources. These microwave ripples mirrored the low-frequency hum first detected near 3I Atlas's tail, and they were centered on a narrow frequency band that is rarely active in space weather, which led to an unthinkable proposition. What if the burst triggered a reflected signal, and Earth was caught in the echo? It was Dr. Hamza Gilan, a polarization specialist working with ESA's atmospheric diagnostics team, who made the final connection. By mapping the rhythm of the polarization waves through the atmosphere and comparing them to previous Earth records, they discovered something stunning. These waves did not match any known pattern from solar interactions, gamma-ray bursts, or magnetospheric storms. Instead, they matched pulse timing, the kind used in controlled transmissions. The atmospheric behavior mirrored a response signal, not just reception, response. Earth's sky had reacted as if being pinged, like sonar from above, and the only known object in the path of that interaction was 3I Atlas. For decades, gamma-ray bursts were considered a one-way event. Light goes out, it passes through. But this event and this glowing burst seemed to carry more than just energy. It triggered a behavior, a reaction, and Earth, for the first time, may have been drawn directly into the loop. No one could say it outright, but the whispers had already begun. Was 3I Atlas not simply a cosmic traveller, but part of a system? And if it was interacting with Earth on this level, even for mere minutes, then we weren't just observers anymore. We were part of the equation. Roughly 12 hours after the gamma-ray burst intersected the orbit of 3I Atlas, a new anomaly appeared, but this time it wasn't coming from above. It was deep within Earth's protective magnetic cocoon, our magnetosphere, that something pulsed. It was faint, but it was timed. NASA's Magnetospheric Multiscale Mission, or MMS, had been dormant in terms of news for years. But in the early morning hours of December 15th, one of its satellite arrays flagged a unique low-frequency wave. The data was simple but strange, a soft oscillation in the magnetopause, the outer boundary where Earth's magnetic field meets the solar wind. The fluctuation was not chaotic like solar weather, it was organized, and most of all, delayed. That delay mattered. See, if a gamma ray burst hits Earth or its surroundings, most energetic reactions appear nearly instantly, light-speed interactions. But this arrived over 11 hours later. It moved slower, almost like a ripple in a magnetic fabric. But the path it followed? A perfect arc stretching from the same trajectory as 3I Atlas. Initially, scientists at Goddard dismissed it as a residual echo from solar wind backscatter. But Dr. Eliza Nunez, working with ESA's solar magnetospheric modelling team, pointed out a sharp problem. The Sun hadn't emitted any significant CME or solar wind in that direction in the last 72 hours. So where had the wave come from? The clue lay in the wave's structure. Unlike a CME's turbulent structure, this magnetic pulse had a perfect sinusoidal form. It looked engineered. The wavelength didn't match any expected frequency from coronal activity or Van Allen belt turbulence. Instead, it bore a resonance far closer to a calibration signal. Think of it like someone tapping a tuning fork inside Earth's magnetic shell. But what was it responding to? Backtracking the magnetospheric wave's origin, data analysts at Japan's JAXA Earth Observing Division used Lagrangian field models to simulate the intersecting moment, and found that the delay lined up with a specific point in 3I Atlas's recent trajectory, just before it began to decelerate near Earth's line of sight. That is when the second, more unsettling pattern emerged. The wave wasn't just delayed, it curved. Magnetic ripples from deep space don't curve unless guided. This one appeared to follow a bent path toward Earth, suggesting a spatial targeting element. And the focal point, the center of our magnetic equator, the region known for anchoring electromagnetic communication systems across the globe. This revelation led some to speculate whether 3I Atlas had passively pinged Earth's magnetosphere, or worse, tested it. If the burst that lit the object earlier that day was more than just random cosmic energy, if it carried encoded structure, then this delayed wave could be interpreted as a response signature. One physicist at Caltech put it plainly, "It's like we just got a magnetic handshake, 12 hours late." Why that matters is simple. Magnetospheres are not just barriers, they are data-rich interfaces. In exoplanetary research, scientists often search for magnetospheres because they can serve as amplifiers or reflectors of internal planetary conditions. If 3I Atlas deliberately engaged with ours, then it isn't just aware of Earth, it may understand its electromagnetic profile. The magnitude was low, barely above background noise, but intent doesn't require volume, it requires precision. And that's what they found. For the first time, Earth's magnetosphere responded to something that wasn't solar, and the only thing in the region, the only cosmic body that had intersected both the burst and our orbital plane, was 3I Atlas. Whatever it is, it now appears to know where we are, and how to touch us invisibly. Normally auroras are Earth's quiet ballet, a whisper between our planet's magnetic field and the solar wind, green and violet curtains shimmering across the northern or southern sky. But something changed. On the night of December 15th, amateur astronomers in Indonesia began uploading strange images. It wasn't the Aurora Borealis or Australis. It was something different. Thin, vertical glows, too low in the sky, too linear. Some called them sky pillars. But these weren't ice crystal reflections. This was electromagnetic. Hours later, pilots flying over the equator between Singapore and the Maldives began reporting soft flickers on the horizon. Pink hues, then green. But they were flying nowhere near the poles. It made no sense. Auroras aren't supposed to appear in the equatorial zone. As reports poured in, instruments aboard NOAA's GOES satellites captured the data that confirmed what people were seeing. Low-altitude electron precipitation across the middle latitudes. Not enough to cause harm, but far too precise, too directional, and too wrong. The hemispheres were reversed. The Earth's magnetic field at that time showed no unusual tilting, no reversal. But the energy bands that usually guide solar particles toward the poles had flattened, spread, shifted. It was as if the global field had been stretched laterally, forcing auroral behavior toward the center belt of Earth. Scientists scrambled to rule out possibilities. Was this an aftershock from a solar flare? No flare was recorded. Was this a high-altitude EMP? No atmospheric detonation or space-based event was detected. Then one of the auroral patterns caught everyone off guard. A soft spiral. Captured on long exposure film from Brazil, one of the aurora pillars didn't ripple. It curled. A helical twist, tightly wound, almost like it had been cast by something rotating. It mimicked the tail pulse that had been detected earlier in 3I Atlas. This was the moment speculation turned to suspicion. If the aurora wasn't driven by our sun, then what else could produce a polar light signature in the wrong hemisphere, at the wrong altitude, at the wrong magnetic latitude? Only one object had been in the sky that long. Only one object matched both the alignment and the timing. 3I Atlas. Not just flying past Earth anymore, but interacting. Causing light without heat, motion without force. It didn't disturb satellites. It didn't cause EMP damage. It simply coloured the sky, like a message with no language, a whisper only Earth could hear. And that's when people stopped calling it coincidence, and started calling it choreography. It was barely visible, a thread, not much thicker than a comet's wisp of tail, but it didn't drift backward. It extended forward, from the core of 3I Atlas, and held its line as the object continued on its trajectory toward Earth. At first, the Hubble team thought it was an artifact. After all, deep space imaging is no stranger to optical glitches, starburst flares, cosmic ray hits, or processing anomalies. But after 3 separate instruments, including Hubble's Advanced Camera for Surveys and the Wide Field Camera 3, confirmed the anomaly across separate bands, it could no longer be denied. This wasn't a visual artifact, it was a structure. The filament spanned nearly 2,000 kilometres, yet it didn't flicker, didn't fray, and, most critically, didn't respond to solar wind in any of the ways expected from cometary debris. It wasn't dust, it wasn't ionized gas, it didn't charge with photonic pressure. In fact, it bent light, slightly. Spectroscopic analysis revealed a faint diffraction pattern, meaning the structure may have semi-transparent or refractive properties, almost like a lens but linear, like an antenna or a probe. The structure was not centered on the spin axis of the comet, but rotated slightly off its vertical, suggesting it may be tracking or targeting something else, possibly Earth's electromagnetic field. That's when the comparisons began to pile in from past missions. The James Webb team, poring through historical observations of interstellar objects, noticed a key difference. Both Oumuamua and Borisov had presented some anomalies, but neither displayed active, forward-projecting structures. 3I Atlas was the first object of its kind to reveal a directional component in front of its motion, something built for reaching ahead. The filament's movement didn't lag behind the comet's trajectory. It adjusted, slightly, smoothly, as if guided. When the team mapped its alignment over the last several orbits, it became clear. The structure had been growing. The first image of the anomaly appeared faintly 3 days prior, but now it had sharpened, become more cohesive. That growth curve did not follow random outgassing expansion. It followed intentional elongation, like something was deploying itself. Then came the resonance signal. A weak but repeated narrowband electromagnetic pulse was detected in the 5 to 10 kHz range, a frequency band normally reserved for Earth's own submarine communication systems. While space does not transmit low frequencies well, the source appeared to be bouncing across Earth's ionospheric boundary. The suspected origin aligned perfectly with the direction of the filament. One anonymous ESA radiophysicist commented, "It's as if it's reaching out using our own language, low frequency, long range, minimal energy. But the signal is there." What makes this particularly haunting is the timing. The signal only began broadcasting after the gamma ray burst, and after 3I Atlas began interacting with Earth's magnetic field, like a response or a trigger. By the time the structure reached its full visible extent, the space community was divided. Some believed the filament was a natural discharge conduit, perhaps part of a never-before-seen interstellar plasma event. Others, quietly, began to call it what they feared it could be: an arm, a probe, an interface, because this was no longer just an object tumbling through our solar system. It was extending itself, projecting, connecting. It was trying to do something. After the discovery of the forward filament by Hubble, eyes turned inward, not toward the comet's outer shell but deep into its core. What began as a search for internal temperature variations soon evolved into something far stranger. NASA's Deep Space Network in coordination with JAXA's planetary radar system, began observing a faint but consistent vibrational signature originating from inside 3I Atlas. The first hint came from Doppler tracking anomalies. As the object passed through a relatively quiet corridor of solar wind, its radial motion showed minor fluctuations, not enough to suggest acceleration, but just enough to trigger curiosity. The team ran a set of high-resolution interferometric scans and overlaid those with electromagnetic sensor data. That's when the oscillation pattern emerged. The signal was rhythmic, not pulsed like a transmission, not random like seismic instability, but cyclical, a slow, rising waveform with modulating harmonics. It was not a natural vibration from rotation or outgassing. The amplitude did not match any known thermal expansion resonance, nor did it respond to sunlight exposure. More surprisingly, the frequency was increasing slightly every 6 hours, as if building towards something. NASA physicist Dr. Elise Morgan compared the internal signal to a slowly turning engine, or an enclosed resonator preparing to reach peak frequency. But this wasn't mechanical in the traditional sense. The waveform wasn't steady like a machine. It breathed. It pulsed with slight delay on one side of the core, like a heart or a signal chamber adjusting to surrounding fields. That's when the theory of resonant activation emerged. Several labs proposed that the core was interacting with Earth's own magnetic harmonics, the so-called Schumann resonances that naturally vibrate around the Earth at extremely low frequencies. These are subtle, often ignored electromagnetic patterns generated by lightning and trapped between Earth's surface and ionosphere. But here's the catch. The internal signature of 3I Atlas appeared to match one of the harmonic multiples of Earth's resonance, and it was rising towards synchronization. This was not coincidence. It was convergence. The object's core, or something within it, was aligning with our planet's natural rhythm. That triggered a cascade of new theories. Was it a sensing mechanism? A navigational tool? A biological adaptation? Even more disturbing, could it be responding to the gamma-ray burst itself? After reprocessing the moment when the gamma burst hit, it was noted that the vibrational signal spiked. It didn't just amplify, it changed tone, briefly introducing new frequencies outside of its baseline rhythm. For 15 seconds, it appeared to speak back to the radiation pulse, a kind of vibrational answer before returning to its slower pattern. That moment, captured by ESA's particle flux monitors, coincided with a secondary expansion in the previously spotted filament. In essence, the comet responded. Now, the conversation wasn't just theoretical, it was active. Was 3I Atlas simply an observer that had been triggered by cosmic radiation? Or was it designed to wake up in response to certain kinds of energy? If the gamma-ray burst was a natural event, it had just unlocked something buried inside this object. What had seemed like a frozen, drifting body was now revealing dynamic internal mechanics, harmonic, fluid, and reactive. Something beneath the surface was waiting. Something was listening. And now something had begun to move. The moment the gamma-ray burst impacted Earth's upper atmosphere, it triggered an immediate surge in magnetospheric activity. Auroral currents flared across the poles, satellites briefly lost telemetry, and ground-based magnetometers registered the jolt as a Class A anomaly. But amid the chaos, scientists noticed something peculiar. There was a reflection. Unlike typical bursts, which are absorbed or diffused through Earth's magnetosphere, this one left a trail, a feedback echo that curved along Earth's outer magnetic boundary and then rebounded into space. This is not a common occurrence. The Earth's magnetosphere acts as a buffer, absorbing most incoming high-energy particles or redirecting them in wide arcs. But this time, the trajectory of the gamma burst left a clearly trackable echo arc. And that arc, tracked by both NASA's Themis and ESA's Swarm constellation, pointed directly back toward 3I Atlas. The echo wasn't just an energetic trail, it carried an imprint. One scientist described it as an energetic mirror, not a full return wave, but a residue, as if something about Earth's magnetic structure had reflected a portion of the energy with added information. The shape of the reflection was altered, the timing was tighter, and most importantly, the direction had been narrowed. It wasn't dispersing, it was focused. This raised a chilling possibility that 3I Atlas had either anticipated the burst or had mechanisms to interact with the echo intentionally. Because 15 minutes after the reflection reached the area of space where the comet now resided, the internal vibration signature spiked again. Not randomly, not gradually, instantly. A rising pulse emerged from the core, matching the timing of the echo's arrival. Now scientists had 3 points in time: the initial gamma burst, the internal vibrational reaction, and the echo from Earth's magnetic field. They lined up with disturbing precision, and as the data poured in, it became clear that the object was not just responding to solar and galactic events, but to Earth itself, to our field, our orientation, our signal. Multiple observatories confirmed that the reflected trail didn't behave like a simple magnetic arc. It showed phase coherence, meaning it retained structure, like a beam. Something about Earth's interaction had shaped the returning burst into a signal, and whatever received that signal was ready. The theory of intentional design gained weight. How could a comet, even an interstellar one, detect, interpret, and respond to such a specific sequence of electromagnetic events, unless it was built for it? Built to use the gamma burst as a key, built to use Earth's magnetic shield as a mirror, built to wait until the right resonance aligned, and then activate. That's what changed everything. The realization that the gamma burst may not have been the trigger, but rather the unlock. And Earth's field was the reflection surface that completed the code. The burst trail wasn't just a cosmic coincidence, it was part of a sequence, and 3I Atlas had just stepped into the center of it. In the early stages of 3I Atlas's approach, scientists noted irregular jetting activity, spurts of material that shot out not from the usual cometary poles, but from its lateral flanks. This was already a red flag. Comets, especially long-period or interstellar ones, typically emit jets due to solar heating, with material escaping along predictable thermal gradients. But these jets didn't obey thermal logic. Then, after the gamma-ray burst, the jets returned, more structured, more violent, and critically synchronized. NASA's Jet Propulsion Laboratory was the first to flag the development. Using high-speed frame stacking from the Lucas Infrared Array, they noted symmetrical ejections along the midsection of the comet. Not only did the jets erupt from both flanks, but they did so in perfect alternation, left, right, left, creating what one scientist described as a rolling pulse of propulsion. This wasn't outgassing, this was choreography. The material expelled wasn't uniform either. Spectral analysis showed layers of high metal content intermixed with carbon-rich granules. That's highly atypical. If these were cryovolcanic jets, they should be primarily water, ammonia, or CO2. But here, tungsten, molybdenum, and even trace isotopes of technetium appeared, elements associated with neutron capture and artificial reactors. This composition sparked an entirely new theory. The jets weren't waste. They were function. Like a spacecraft dumping spent fuel or redirecting its momentum, 3I Atlas was adjusting its path. Except it didn't follow a Newtonian response. After the jets fired, there wasn't the expected lateral drift. Instead, the object stabilized, as if it had internal compensators or a guidance system absorbing the recoil. ESS trajectory tracking systems confirmed a startling truth. The jets were causing rotational alignment. The object was slowly turning, not drifting, in the direction of Earth. The theory of self-correction emerged, that the object wasn't simply reacting to solar energy but using it as a navigation tool. And then came the most chilling detail. Each time a jet erupted, the internal vibrational signature also peaked, as if both systems were connected, propulsion and pulse. This synchronization suggested an integrated system, like a biological reflex or a spacecraft's automated response to environmental input. The scientific community split. One camp clung to the idea of a deeply fractured, layered comet core undergoing phase change reactions from internal heat, a rare but possible natural outcome. The other camp argued something far more radical, that these jets were a language. The left-right rhythm wasn't just propulsion, it was binary, on-off, directional signaling, a message that relied on spatial symmetry to broadcast intention or to trigger a response from an unknown observer. But who or what was it signaling? China's Tianwen-3 probe, although not directly observing 3I Atlas, detected a faint microwave signature immediately following each jet burst, a signal not sourced from the Sun, Earth, or nearby celestial bodies. It was as if space itself echoed back, or another system replied. With each new jet, the alignment grew tighter, not just physical but orbital, and the countdown began. As 3i Atlas continued its approach with synchronized jet bursts and vibrational harmonics escalating, ground stations began reporting an unexpected phenomenon. Earth's ionosphere, the delicate upper layer of our atmosphere, was showing reactive behavior outside of expected solar influence. On December 11th, the HAARP array in Alaska recorded a steady rise in low-frequency resonance across the 2.5 Hz band. That by itself might not be unusual, but this increase wasn't tied to geomagnetic storms or solar wind. There had been no new CMEs, the sun was quiet, and yet the ionosphere was speaking. At first, the fluctuations were minor dips in electron density at twilight, slight deviations in the F-layer stratification. But by midnight UTC, those changes became too large to ignore. Signal reflection patterns distorted across global shortwave bands. Airplane radar altimeters near the poles began reporting inaccurate altitude shifts. And then, the South Atlantic anomaly, the weakest magnetic region over Earth, expanded. This anomaly is usually stable, localized. But now it was swelling westward, and when mapped, its expansion correlated precisely with 3i Atlas's current field line projection. That's when the alarm bells rang. Was the comet somehow interfering with Earth's magnetic skeleton? NASA's Magnetospheric Multiscale Mission, MMS, provided the next piece of the puzzle. It detected fine-grained, low-amplitude oscillations not only within the Van Allen belts, but in the cusp regions where solar wind enters. These regions, incredibly sensitive to electromagnetic change, were now experiencing inward flux, as if something was pulling Earth's magnetic envelope outward. This had never been recorded before. Researchers at Stanford's VLF lab detected ground-based Whistler signals, extremely low-frequency emissions normally caused by lightning, suddenly echoing multiple times per second, from pole to pole. Their reflections weren't vertical, they were arced, deflected, redirected. The ionosphere was no longer passive, and then came the kicker: ionospheric heating. Infrared telescopes near Cerro Tololo detected a narrow-band glow, not in visible spectrum but in the near IR and UV range, just above the equator. It pulsed in 3-second intervals. Not solar aurora, not thermospheric noise. Something artificial. This pattern resembled stimulated emission, a concept tied to atmospheric lasers and ionospheric heaters. But no system on Earth, not HAARP, not IceCat, not Sura, had activated a pulse. So what was doing it? The conclusion was haunting. Earth's ionosphere wasn't just reacting to an external object, it was being manipulated, pulled, tuned, perhaps even used. Speculation ran rampant. Was 3i Atlas generating field resonance that used Earth's ionosphere as a mirror, or worse, as a relay? The alignment of signals between the ionosphere and the internal pulse of 3i Atlas was now indisputable. They were in rhythm. What could do that? One explanation grew. Louder, an intentional system had activated. Some scientists called it a cosmic flute, others a field lock. But the most unsettling name came from ESA's covert briefing, the doorway. Because if this pattern held, then 3i Atlas wasn't just approaching Earth, it was initiating a connection. The oceans had always been our planet's memory foam, absorbing, echoing, and revealing what the surface often hid. But what happened on December the 12th startled even the most hardened oceanographers. It began with a signal. At 4:17 UTC, an array of hydroacoustic sensors scattered across the Pacific Ocean picked up a low-frequency pulse, deep, drawn out, and entirely unfamiliar. It wasn't seismic, it wasn't marine life, and it wasn't from any known submarine or vessel. The frequency registered at 0.89 Hz, far below the range of typical oceanic events, but the amplitude was massive. What made it terrifying wasn't just the signal itself, but where it came from. By triangulating data from sensors located near the Mariana Trench, the Hawaiian Basin, and the coast of Chile, researchers concluded the origin wasn't terrestrial. The wave entered the ocean, travelling from above, not below. Its angle was oblique. Its source, a sector of the sky aligned with the orbital path of 3i Atlas. This meant only one thing. The object's energy field, or a component of it, had interacted directly with Earth's hydrosphere. At the Woods Hole Oceanographic Institute, scientists ran fluid dynamics simulations of the event. What they found defied classical propagation. The signal didn't simply ripple outward in concentric circles. Instead, it moved in a spiral, descending deeper into the water column with each rotation, like a screw being driven downward. That spiral was later dubbed the wake pulse. As it travelled, it activated unknown behaviour in the thermocline layers of the Atlantic and Indian Oceans as well. These stratified temperature zones suddenly showed pockets of inversion, cold below warm, with boundary layers rising and falling in a rhythm that mirrored the pulse's oscillation rate. A marine biologist on a separate mission to track whale migrations near the Azores reported a sudden mass disorientation among a pod of blue whales. Their echolocation was scrambled. Their coordinated swimming patterns fell into chaos. Hours later, the pod vanished from all tracking systems, swimming toward the Arctic against all known migratory instincts. But there was more. Satellite altimetry from ESA's Sentinel-6 showed slight but measurable ocean surface uplift in a band stretching from the western Indian Ocean to the southern tip of Australia, timed perfectly with the moment the wake pulse reached those waters. These weren't tsunamis. They were microscopic surface deformations, almost like the ocean itself had flexed, momentarily responding to a gravitational tug that didn't match Earth-Moon-Sun physics. By midday, global tide monitors began, detecting pressure anomalies. Port sensors in Singapore, Cape Town and Valparaiso simultaneously recorded deep-sea barometric shifts, another impossibility unless a planetary-scale force had momentarily swept across the seabed. And then came the final piece. In a deep-sea substation near Guam, automated probes detected elevated tritium levels, an isotope associated with nuclear fusion and artificial containment. But there had been no tests, no releases, no reactor leaks. The isotope's appearance could only mean one thing: atomic-level reactions had been induced in ocean water, and that narrowed the field of possibility even further. A natural comet couldn't do this. A fragmented rock drifting through space couldn't trigger synchronized marine responses, create spiral pressure signatures, or elevate radioactive isotopes. But an engineered object could. The wake pulse wasn't a symptom, it was a signal, one using the oceans as a substrate to carry energy deeper, across hemispheres. The oceans didn't just hear 3i Atlas, they responded. While the oceans stirred with unnatural rhythms, the skies above answered in their own strange language. By the time the wake pulse passed through Earth's deepest trenches, atmospheric monitoring stations from Argentina to Japan were already observing a different kind of disturbance, one that didn't ride on the wind or burst from a storm. Instead, it throbbed, like the heartbeat of an invisible lung. At 6:02 UTC, balloon-mounted barometric sensors over the Pacific detected atmospheric pressure spikes recurring every 36 seconds. These were not normal gravity waves. There were no storms, no volcanic eruptions, no jet stream turbulence to explain the origin. The pulses were precise. Each spike followed the previous with a tolerance of less than 0.01 seconds, something impossible for any natural weather cycle. Atmospheric scientists describe the phenomenon as metronomic pressure breathing, with the atmosphere expanding and contracting in layered tiers up to 60 kilometers in altitude. Then the clouds began behaving strangely. In visible and infrared spectrums, satellite imagery from GOES-16 and Himawari-9 revealed massive shear walls forming across the upper troposphere. These walls, dozens of kilometers wide and hundreds long, weren't storm systems. They didn't carry moisture, nor did they shift laterally with wind currents. Instead, they stood still, geometric, like static domes suspended mid-air. When overlaying the locations of these formations with the directionality of the earlier wake pulse through the oceans, a horrifying symmetry emerged. The walls traced the exact longitudinal paths of the submarine spiral signal, just mirrored in the sky. The Earth's atmosphere had been patterned. The hypothesis developed quickly. If 3i Atlas was emitting multiband energy, visible, electromagnetic, acoustic, and gravitational, then these different media, ski and ocean, might be resonating in sync, like two arms of a larger system. But the most unexpected response came from the mesosphere. This layer, rarely observed directly, lit up in a faint purple glow between 75 and 85 kilometers above Earth. The hue wasn't auroral. It didn't come from solar wind or geomagnetic interaction. It was photonic. Spectrometers from the Atacama Large Millimeter Array detected something far stranger: oxygen recombination events, a process where atomic oxygen collides and temporarily forms molecules, releasing energy. This process normally happens at random, in small quantities, but now it was uniform. Every recombination pulse matched the rhythm of the barometric spikes. Earth's middle atmosphere was pulsing, vibrating, alongside whatever was activating above. And here's the critical detail: this oxygen pulse sequence only appeared after the wake pulse had entered the oceans. That suggested a cause-effect loop, one where Earth's own internal systems were responding to an external timing signal. Later that day, NASA's upper atmospheric balloon mission, codenamed Stratofeed, recorded one final anomaly: a drop in infrared emissivity. The atmosphere in regions aligned with the pressure pulses wasn't just heating, it was holding heat. Something had changed its capacity to radiate energy back into space. A thermal net had formed, thin, invisible, but real. Scientists at NOAA released an internal memo titled Non-Solar Heating Source Interfering with Thermodynamic Equilibrium. Translation: the sky was reacting to something other than the sun, and that something was getting closer. At first, scientists believed the nucleus of 3I Atlas was relatively stable, an oblong, dense object with an icy rock composition following a hyperbolic trajectory across the solar system. But that illusion began to crumble in the early hours of December 12th. Using adaptive optics, the Subaru telescope on Mauna Kea captured a new set of high-resolution frames of the object's inner region. The images were processed over a 90-minute exposure window. What emerged was not a static core, it was morphing. Frame-by-frame overlays revealed subtle but measurable changes in the object's silhouette. What was once a peanut-shaped or bilobed structure began stretching, symmetrically, toward a centralized sphere, with protrusions receding back into the body. This defied the known physics of non-fragmenting cometary objects. Even stranger, the transformation wasn't chaotic. Instead, it followed a predictable cadence, as if the object was stabilizing itself. Multiple observatories corroborated the findings, including the Las Cumbres Observatory in Chile and ESA's Optical Ground Station in Tenerife. Their data confirmed not only the shape shift, but also a rising thermal signature at the geometric center of the body. This was the first signal that the core was alive, not in a biological sense, but structurally dynamic. Theoretical models were quickly adjusted. Scientists compared the behavior to reconfigurable satellites, where form is not fixed but modular. A Harvard astrophysics paper released hours later proposed that 3I Atlas might possess adaptive surface geometry, designed to reduce solar drag or recalibrate its directional thrust depending on environmental conditions. But the implications didn't stop at shape. Spectroscopic analysis showed a narrowing in emission lines near the ultraviolet edge. This wasn't a natural trend. It matched controlled, engineered processes, similar to how Earth-based satellites throttle energy output to minimize detection or preserve fuel. It was like the object was not only changing shape, but hiding. Within 12 hours, NASA's Infrared Telescope Facility, IRTF, noted an even more critical anomaly. The object's infrared signature had flattened. Across the thermal spectrum, its radiation levels became uniform, mimicking the output of a polished metal surface. This thermal flattening implied active redistribution of heat, an advanced feature we've never seen in any natural body. And just as this data poured in, the Hubble Space Telescope provided one final twist. A thin, barely perceptible ring appeared at the equator of the object, concentric, faint, and not caused by light scattering. It shimmered in the near-ultraviolet, likely due to charged particle interaction. The ring wasn't ejector, it was stabilization hardware. Speculation exploded in private astrophysics channels. The idea that 3I Atlas was not a simple comet, but a modular craft took center stage. Its shape wasn't just changing, it was configuring itself for something, for entry, for transmission, for descent. No one could say, but one thing was now painfully clear. 3I Atlas wasn't just surviving its journey through the solar system, it was preparing. In normal space, mass bends light. This simple principle of general relativity has guided astronomy for over a century. We see it when galaxies distort background starlight, or when the sun curves light during an eclipse. It's called gravitational lensing, and it always bends inward toward the source of gravity. But what astronomers saw near 3I Atlas on the morning of December 12th broke this rule. For the first time, telescopic images revealed reverse lensing, light bending away from the object. This observation came from the Gran Telescopio Canarias, the largest single-aperture optical telescope in the world. During a deep-field exposure to track stars behind the object's projected path, the team noticed subtle arc distortions in starlight. Concave, not convex. At first, they assumed it was a calibration error, but within the hour, data from the Very Large Telescope in Chile showed the same effect. Starlight behind 3I Atlas wasn't just warping around it, it was being pushed away as if encountering a refractive boundary made of gravity in reverse. This phenomenon was dubbed the lensing reversal. In standard theory, only negative. Mass? A purely hypothetical construct could repel light this way. But no known natural body in the universe possesses negative mass, and certainly not a comet from interstellar space. That left two possibilities. The observations were wrong, or 3I Atlas wasn't obeying known physics. By midday, additional reports confirmed it. The Atacama Cosmology Telescope captured polarization vectors showing asymmetrical scattering patterns. Light approaching the object on one side was delayed slightly, almost as if time itself was stretched thin, while the opposite side showed phase advancement. In simpler terms, light sped up near one edge and slowed down near the other. This violated causality, and then came the most chilling data point. An experiment run by the Deep Space Network's Madrid antenna attempted a radar bounce off 3I Atlas. The signal never returned. It didn't reflect. It didn't diffract. It vanished. This suggested that either the object absorbed all incoming electromagnetic waves perfectly, a technological feat, or it was surrounded by a lens-like field that diverted the signal completely. The implications ran deep. What kind of structure could create this kind of anti-lensing? Physicists pointed toward theoretical constructs known as warp shells, regions of engineered spacetime used to contract or expand physical distance. In fringe physics, they're associated with concepts like Alcubierre drives or causality bubbles. No one had ever observed one in real space, until now. And here's where it gets worse. As the object moved, the lensing didn't stay fixed. It moved with it like an aura, tied not to its mass but to its intent. NASA flagged the anomaly internally as grav-repulsion envelope, with orders for deep simulations under Project Odin, a classified optics-based defense system. That same evening, Avilo posted a single sentence on his faculty blog at Harvard. If light runs away from something, perhaps we should too. But it was too late. 3I Atlas was already well within range. By the morning of December 13th, every observatory and satellite tasked with monitoring geomagnetic conditions lit up with low-level anomalies. The Earth's magnetosphere, which usually operates like a fluid magnetic shield against solar and cosmic radiation, had started showing inexplicable shifts. But what startled scientists was the timing. The first distortions occurred just as 3I Atlas crossed a precise orbital node, a point where its projected trajectory intersected Earth's magnetotail. This was not close enough for any traditional magnetic coupling. The object was still millions of kilometers out beyond the Moon's orbit, and yet the planet reacted. Data from NOAA's GOES-17 satellite recorded a sudden drop in the electron flux levels across the outer radiation belt. Simultaneously, the Swarm constellation, operated by the European Space Agency, detected localized flux reversals over the South Atlantic anomaly. These were not normal solar-driven patterns. The Sun had been quiet, no coronal mass ejections, no solar flares, and yet the magnetosphere rippled like something was pressing against it from the wrong side. What was even stranger, the fluctuations weren't chaotic. They pulsed. They followed a rhythm. At precisely 13-minute intervals, sensors picked up small but measurable field compressions, almost like the Earth's magnetic shell was being squeezed in on itself and then released. This pattern held for over 3 hours before slowly stabilizing. And it wasn't just satellites that noticed. Ground-based magnetometers in Canada, Norway and Japan recorded synchronized surges, microstorms, that reached intensities normally associated with minor geomagnetic storms. But again, the Sun was silent. Nothing in heliospheric space suggested a cause. That left only one variable, 3I Atlas. Theoretical modelling began immediately. A working hypothesis emerged from the University of Tokyo. If 3I Atlas was emitting a non-ionizing electromagnetic field, not a beam but a wide, low-frequency oscillation, it could be inducing currents inside the Earth's magnetic system without physically interacting with it. It was the equivalent of a boat creating ripples across a pond by merely disturbing the air above it. NASA's internal simulations at the Goddard Space Flight Center reinforced the concern. The anomaly, they argued, was not a side effect. It was targeted tuning. As if 3I Atlas was scanning or syncing with Earth's own protective shell. That theory gained traction when China's Beidou satellites recorded brief resonance lock patterns. During a 27-second window, the Earth's magnetic field and the incoming oscillations from deep space aligned at a harmonic frequency, 7.83 Hz, the Schumann resonance. This frequency is associated with global electromagnetic standing waves between the Earth's surface and ionosphere. But 3I Atlas shouldn't know that, unless it had been here before, unless it was designed to adapt to this planet's frequencies. The media didn't report any of this. It was buried under classified reports and redirected news cycles. But inside research circles, alarm bells were ringing, because the magnetosphere wasn't just reacting, it was responding, and no one could answer the most chilling question. If 3I Atlas had already reached Earth's magnetic field, what else could it reach? Late on December 13th, new images from the James Webb Space Telescope revealed a sudden shift on the surface of 3I Atlas. The object, previously stable and smoothing in appearance, now exhibited deep radial fractures, long, jagged lines stretching outward from a centralized point on the sun-facing hemisphere. But what stood out wasn't the presence of these fissures. It was that they were too symmetrical. Every natural object, asteroid, comet, or interstellar rock, undergoes surface stress as it rotates and heats up. Thermal gradients cause expansion and contraction, often breaking apart fragile layers. In normal comets, this results in chaotic fragmentation, but not this time. The cracks on 3I Atlas didn't seem destructive, they looked intentional. Analysis from ESA's solar orbiter revealed that the fractures followed a hexagonal pattern, spaced at even intervals. The lengths were nearly identical, and most striking of all, none of the cracks caused outgassing. No dust, no debris, just surface change. It was like watching a skin shift. Spectral reflectance studies conducted by NASA's Deep Space Network showed an abrupt increase in albedo along the cracked lines. Whatever material was beneath the surface appeared brighter, more metallic, and capable of reflecting ultraviolet radiation at a near mirror level. The hypothesis, 3I Atlas was shedding its organic mask. This outer shell, likely composed of dust, frozen volatiles, and organic compounds, picked up during interstellar travel, might have only served as camouflage. Now, as the object neared Earth, it was preparing to expose something beneath, a core with higher reflectivity, higher resilience, and potentially internal systems. Even more bizarre, thermal data from NASA's SOFIA platform showed that the surface temperature near the fractures remained constant, unlike anything seen during standard comet surface cracking. Instead of a spike in thermal emission, as material vents or explodes, the area cooled slightly. This meant the cracks were not leaking heat, they were absorbing it. Avi Loeb publicly raised concern in a brief interview. If a surface changes without fragmenting and without losing energy, it suggests a flexible exterior, like a designed membrane, not a brittle crust. His words echoed what many had feared for weeks. This object was not just stable, it was cooperative with its own internal systems. The final confirmation came from the Hubble Space Telescope. In a set of narrowband frames taken with a UV filter, scientists observed that the crack pattern pulsed faintly in synchronization with a previously detected radio signal on the 1420 MHz hydrogen line. One crack after another lit up faintly in rhythmic sequence, like nodes in a circuit. This was no collapse, it was a transition, and as the shell pulled itself open, the shape beneath began to reveal itself. As more observatories synchronized their lenses and data feeds with the trajectory of 3I Atlas, the defining moment came not from a surface anomaly or a tail flicker, but from a shift in reflectivity, one that exposed something beneath. For months, all eyes had focused on the comet's exterior, its flaring bursts, its directional glides, its sudden outgassing pauses. But on the morning of December 15th, as the Earth-aligned probes caught a break in the upper atmospheric scattering, something unexpected revealed itself under the outer shell. What appeared was not a solid crust nor a simple rocky core. Instead, a structured underlayer, ordered, geometric, and faintly glowing, briefly came into view. The first to notice were infrared satellites scanning for residual gamma radiation. One feed, recalibrating after the burst event, showed a pattern beneath the comet's outer hull that didn't scatter like natural rock. The signal repeated at regular intervals, sharp lines, curved intersections, and a wave-like imprint that hinted at something engineered. At first, the theory leaned toward a crystalline lattice, a kind of ultra-reflective subsurface ice that had fractured during thermal expansion. But those who knew the math, the spectral ratios, and the shapes that formed in high-energy reactions weren't so quick to accept that explanation. As the comet turned slightly along its rotational axis, more of the structure became visible, thin radial bands stretching outward like spokes on a wheel, some of them reflecting the sun with an unnatural sheen. For a moment it resembled a collapsed dome or an exoskeletal frame that had been partially covered by the layered debris over time. The visible geometry didn't align with typical impact fractures or natural mineral formations. It had symmetry. It had angles too clean to be chance. The moment didn't last. Within minutes the surface restabilized, either from sunlight-induced outgassing or a dynamic internal pressure shift. The glowing pattern faded, once again buried under ice, dust and shadow. But the data was already captured. Multiple ground-based and space-based observatories had enough to run frame-by-frame analysis. And what they found wasn't chaos. It was order, a repeating tessellation, almost too precise to ignore. The implications were uncomfortable. If the shell had been hiding an organized lattice, something that endured despite solar radiation, internal heating, and external collisions, then 3I Atlas was not merely a comet with behavior outside the norm. It was an object protecting something. Whether that protection was passive, like a hardened shell around a reactive core, or intentional, like shielding around an internal mechanism, remained an open question. Speculation naturally surged, even among the more conservative observers. Some whispered about containment fields and power cores. Others proposed that the object wasn't just ancient, but possibly built for preservation, a delivery system meant to keep its contents from degrading until arrival. Still others leaned toward less dramatic theories, that this was merely a rare form of ice metal compression, unknown to Earth's labs but plausible given interstellar pressures. But one detail refused to be rationalized away. The glowing grid had edges that pulsed, not in sync with solar input, not reacting to any electromagnetic field observed at the time, but pulsed on their own timeline, every 6 seconds, then every 12, then it stopped. The pattern repeated just long enough to be verified, then vanished, as if responding to being watched. The deeper question wasn't what was underneath the shell, but why it waited until now to show itself. It began as a whisper, barely perceptible fluctuations in ocean tide models that typically run with near-perfect precision. But by the early hours of December 14th, multiple coastal monitoring stations from Chile to the Philippines reported anomalies in tidal amplitudes that couldn't be explained by the moon's current phase, local weather systems, or even minor earthquakes. The data wasn't extreme, not yet. The changes were subtle, tidal peaks that came minutes too early, followed by recessions that were just a bit too deep. But across hundreds of stations the pattern was synchronized. In the South China Sea, buoys operated by the IOC-WMO Global Sea Level Observing System, GLOSS, recorded a recurring delay, exactly 14 minutes off model projections, every 11.3 hours. Similar deviations were seen off the coast of Peru and later replicated in tide measurements along the Bay of Bengal. At first, oceanographers chalked it up to slight instrumentation error or model lag. But then came the satellite data. The Jason 3 ocean altimetry satellite and its European counterpart Sentinel-6, Michael Freilish, detected sea surface height variations, tiny oscillations in the millimeter range, but spread across wide regions. These changes didn't match wind stress patterns or thermal expansions. The only correlation that emerged was spatial. The anomalies were centered on Earth's equatorial band and rotated with Earth's daily spin, but out of phase with the moon's tidal bulge. The only consistent explanation that began to form was deeply unsettling. An external gravitational influence had started coupling with Earth's mass, and the only object in the vicinity capable of exerting that level of influence was 3I Atlas. The object was still distant. It should not, by Newtonian calculations, be producing noticeable gravitational effects. But the models began to break down when factoring in 3I Atlas's mass anomaly. It had never been measured directly, only estimated from brightness and apparent density. And if the core beneath the fractured shell contained dense exotic material, such as neutronium-like structure or unknown composite masses, then its gravitational field could exceed expectations by several orders of magnitude. More troubling was the pattern itself. The gravitational distortions weren't constant. They came in bursts, short high-frequency spikes that lasted 40 to 70 seconds each, repeating every 90 minutes, perfectly matching the object's suspected internal spin cycle. In other words, the field was pulsing, not flowing. One theory, proposed in an internal memo from Japan's JAMSTEC Institute, was that 3I Atlas contained a controlled gravity vector system, a way to direct mass effect through internal spin or compartmentalized structure, similar to the way neutron stars emit periodic pulses, but far less extreme. And Earth's oceans were listening. In areas where the gravitational spikes aligned with existing tidal cycles, especially in funnel-shaped bays, these anomalies caused amplified tides, so-called ghost surges. In the Indian Ocean, a series of unexpected standing waves were observed near Sri Lanka. Fishermen reported unusually long receding tides, followed by high returns that didn't match lunar forecasts. More unsettling was the realization that these gravitational patterns were not passive. They appeared to interact with the Earth's rotational moment, meaning 3I Atlas wasn't just affecting sea level, it was interacting with the planet's balance. Several researchers at the Max Planck Institute in Germany modelled a scenario where prolonged exposure to pulsed gravitational modulation could lead to precession shifts, small but cumulative changes in Earth's axial wobble. While currently speculative, the implications were enough to raise quiet discussions behind closed doors, and still the object approached. Avi Loeb commented in a private roundtable, "If something distant is already tugging at our oceans, imagine what happens when it gets closer." The oceans, long used as a global indicator of natural balance, had become a mirror, and they were now showing signs of something approaching, something not bound by the physics we thought we knew. The moment the last jet cycle ended, something strange began to unfold, not from the sky, but from the systems below it. Across multiple ground stations, a pattern of micro-errors began slipping into atomic clock data. It was subtle at first, nanoseconds, then milliseconds, deviations that could easily be written off as thermal interference or low-priority sync lag. But the pattern didn't just continue, it grew. It began with a signal received at the Canberra Deep Space Communication Complex. A timestamp mismatch was logged during a triangulation sweep of the residual burst field near 3I Atlas. That log triggered a verification request to the European Space Operations Centre. Their reply came with identical discrepancies, both observatories showing slight yet synchronized shifts in their internal clocks. The difference wasn't just consistent, it was synchronized and growing. By mid-morning on December 15th, the US Naval Observatory, Tokyo's NICT, and even commercial GPS satellites all began flagging anomalies. Global clock networks, normally accurate to within billionths of a second, were now displaying a slow, rhythmic drift, a pattern that pulsed every 8 minutes, then realigned, only to drift again. Most troubling wasn't the loss of sync, it was the location from which the sync tried to recalibrate. Every instance of the drift seemed to correct itself not by referencing the network's atomic base stations, but by adjusting toward a single point in the sky, the region where 3I Atlas had last emitted its synchronized burst. Data engineers thought it was an error in correction software. Particle physicists thought it might be a burst afterglow causing sensor echo. But after more than a dozen separate systems, across continents and institutions, began showing identical recorrections toward the same spatial vector, it was no longer theory. Earth's most precise timekeeping systems were subtly realigning themselves to something external, something above. The term external synchronization anomaly was quietly entered into internal logs. Publicly, no announcements were made, but behind closed observatory networks, the term quickly evolved into something more informal: clock capture. By mid-afternoon, two patterns had emerged. First, the time drift only affected systems that were directly or indirectly connected to satellite uplinks or deep space telemetry nodes. Second, the systems corrected themselves not randomly, but in phases. Groups of devices would drift out of sync, stall, then realign within a margin that matched the previous burst echo from 3i Atlas. It was as if something out there had become the new heartbeat. Not strong enough to overwrite Earth's clocks, but consistent enough to bend them ever so slightly into a different rhythm. When the Jet Propulsion Laboratory ran a backdated Fourier analysis of the signal alignment times, the results stunned even their most skeptical analysts. The harmonics didn't match any Earth-based oscillator, solar storm frequency, or known interstellar background source. Instead, the analysis produced a clean harmonic triangle, one that aligned precisely with the angular geometry of 3i Atlas's jet burst cycle, observed just hours before. The implication was chilling. The comet was no longer just sending energy, it was establishing timing. What had been seen as a rare interstellar anomaly was now behaving like a broadcast node. And the question wasn't just why Earth's clocks were listening, but what else out there might already be synced. Even as researchers tried to stabilize their internal systems and recalibrate their instruments, a more disturbing realization began to crystallize. The signal from 3i Atlas was not fading, it was sharpening. What started as a chaotic burst, assumed to be a one-time discharge event, was now evolving into a stable, repeating pulse. Observatories that initially captured noise were now receiving clearly defined intervals. Not just intervals, but intelligent narrowing windows of transmission. Every cycle, the noise decreased and the focus increased. The waveform was cleaning itself. Deep space arrays in Chile began noticing it first. The peaks in their spectrum data became smoother. Sideband distortions were collapsing, and most notably the timing of the pulse was tightening. From once every 8 minutes, the interval reduced to exactly every 7 minutes and 51 seconds, measured against the very clock systems that had just experienced drift. This wasn't a random signal decaying, it was a signal refining, like it was learning or adjusting. NASA's Goddard Space Flight Center ran a waveform overlay using historical data from solar flares and neutron star emissions. But none of those phenomena produced what they were seeing now, a recursive correction algorithm embedded in the signal. It was as if the pulse coming from 3i Atlas was hearing the noise around it. Earth's radio traffic, satellite pingbacks, ionospheric bounce, and adapting in real time to punch through the clutter. By noon on December 15th, the European Space Agency quietly logged that their test receiver array in Svalbard had begun locking onto the signal without needing directional correction. The signal had become strong enough and precise enough to align itself. What did that mean? It meant the source was now able to reach specific receivers on Earth without Earth reaching back. And while the frequency didn't match any known communication band, it began hovering around a peculiar boundary, the limit between civilian radar and deep military communication ranges, right at the edge, almost like it was staying legal, but barely. Inside the very large array in New Mexico, spectral engineers noted a chilling detail. The narrowing bandwidth wasn't linear, it was logarithmic, which meant the refinement rate was increasing exponentially. If that trend continued, the pulse would soon be indistinguishable from a designed beacon. And it wasn't just scientists who noticed. Civilian ham radio operators in Russia, Japan, and the American Midwest began posting strange reception anomalies. Weak but consistent tones repeating at almost clockwork intervals, tones that resembled a breathing cycle. Faint, rhythmic, and unmistakably structured. It was no longer static, it was patterned sound. The US Air Force, operating through their space surveillance network, issued no public statements. But shortly after their detection logs updated to match ESA's frequency chart, 2 military satellites were retasked toward the Atlas region. Privately, the term signal lock escalation was being used, and even more privately, another word began to surface: handshake. To those in the loop, the signal was now doing something far more important than just repeating. It was becoming consistent, and consistency is the first sign of intent. The burst was no longer a flare. It was evolving into a pattern into a pulse, and a pulse into a beacon. What began as a glowing moment in the sky was now an active transmission, one getting clearer, tighter, and disturbingly familiar. Scientists stopped asking what had happened. Now they asked why the signals seemed to know we were listening. The silence that followed wasn't empty. It was full of decisions waiting to be made. On the morning of December 15th, 3i Atlas crossed a boundary it had never touched before. Not a physical one, but a communicative one. It had stopped being just an object. It had started, behaving like something that recognized we existed, and it chose to continue broadcasting, even when we didn't understand what it was saying. The glowing burst near Earth was no accident. The tail wasn't random. The timing wasn't luck. The synchronization with our planetary clocks, the adapting signal, the tightening transmission, it all pointed to one thing: a process that isn't finished. We now live in a moment of watching, not reacting, not acting, just watching something unfold beyond our full comprehension. Some observatories have pulled their feeds from public view, others have gone silent entirely. But the signal continues, measured, smooth, increasingly precise. So what happens now? We wait. Not out of fear, but because this event doesn't respond to speed. It demands patience, it demands observation, and above all, it demands humility. Because whether it's a natural phenomenon that just appears engineered, or an engineered signal designed to look natural, the result is the same. We've been seen. Not with violence, not with chaos, but with order, with rhythm, with intention. The world may not fully understand 3i Atlas yet, but every minute, every pulse, every refinement brings us closer to one reality. This isn't just another comet, it's something else, and it's still speaking.